So let's take this a bit further. We're going to use what we learned last time. What we learned. We learned that if you have A times B in a determinant, you can replace that with determinant of A times determinant of B. So we'll be using that idea. So the idea here is that I have, well, I can break it up like right here. I'll think about this product in green here times B A transpose. But then I can use this idea again. I can use it here and I can use it here. So I get so the A squared in the determinant becomes this guy. And then you have determinant of B, determinant of A transpose. So this became this. And then finally, you know that the determinant of A transpose is the same as the determinant of A. Okay, so these two things and this thing, they're all the same. So in fact, I get determinant of A cubed times determinant of B, which I can work out with my given numbers here. So I get negative 2 cubed times 3, that is minus 24. Okay, the determinant of A inverse. This is a bit trickier. I'm going to think about this. I'm going to be clever, as I usually am. I'm going to go A times A inverse is the identity, right? And then I'm going to say, well, I'll do a determinant of both sides. What happens? Math the magic. Now, determinant of a product is the product of the determinants. The determinant of the identity is going to be 1. How do you figure that? Well, if you have the identity like this, the determinant is going to be, well, 1 cubed, right? You just do the product of those diagonal entries. What do I care? Well, I have a formula for the determinant of A inverse now. It's going to be 1 over the determinant of A, provided that this number is non-zero. So here we have a nice formula which should have a special place in your notes. And we'll use it in part B here. So use our formula. And this is 1 over negative 2, if I'm not mistaken. Yeah. Part C. Part C is another thinker. Have a think about this. So we got 2B. So we're going to do this as follows. We're going to remember that B is the same thing as I times B. Right? Because in the land of matrices, the matrix I is kind of like the number 1. So we're going to go 2IB. So a clever trick, because if we think of it like this, 2I times B, putting in brackets to emphasize something. Now we can use the fact that the determinant of a product is the product of the determinants. And this guy we can figure out now. Because what is it? 2 is 2I. That is equal to this matrix. So that determinant is going to be 2 cubed times the determinant of b, which, if I'm not mistaken, is 3. Let's just zoom out a second here. 3, yeah, it's 3. So I got 8 times 3 is 24. Okay, so maybe in general we could say that if I have say a number times a matrix, and I do a determinant, okay, what happens is that the number comes out, but you put this exponent on it. So we'll put n, u to the n, times the determinant of a. So this is u is a real number, and a is n by n. Okay, another formula that should have a nice place in your notes.